For lesson 10, we're going to concentrate some more on domain. Is going to be the main idea you're going to be looking at in here. We'll do range stuff with some of this as well, but mostly we're going to be talking about domain, and I'll show you why as we go through. Okay, let's say you're given a graph here and you're asked these particular questions. The thing to remember about the notation that goes along with this is what's on the inside is your didn't work, sorry. What's inside, do that, is your x, and what is comes on the outside is the y. So if I have f of -1, that would be, what would the y coordinate be if the x coordinate is -1? Well, that in this case would be 3. On this one, if the y coordinate is 2, what is the x? I'm sorry, -2. What would be the x coordinate? So if I have a y coordinate of -2, I actually have 2 x coordinates. I would have both 1 and 4. So 2 answers on that one. All right, domain, again, is how far something stretches left and right. So the farthest left that goes is 3, and then it continues all the way on, -3, excuse me, it continues all the way on to 5. It does not include the 3, but it does include the 5. So I would have -3 is less than x is less than or equal to 5 for the domain. And the range is, again, up and down. The lowest that goes is -4, and the highest it goes is +3. So -4 less than or equal to, because it does include that point here, less than or equal to y, less than or equal to +3. Again, it includes that point, so that's why you put the equals. So when we're doing domain, there's going to be 2 main ways that you'll find it. One would be like what we just did a second ago. Have a graph, take a look at it, see what it is. If the graph's already drawn for you, that's nice. If you have the equation, you're going to need to decide whether it's worth your time to take that and actually graph it or not. You can. That's kind of up to you. It would kind of depend on what was given and how hard it would be to graph. Algebraically, a lot of times it's easy enough to do because really you're only going to look for 2 things. You're looking for when you're dividing by 0, and you're looking for square roots, because first of all, you can't divide by 0. If you take your calculator and do 5 divided by 0, your calculator will give you an error. You just can't divide by 0. So denominator can't be 0. And you can't have negative square roots, because remember, negative square roots give you imaginary numbers. So you don't want something number divided by 0, and you don't want the square root of a negative. Those are the 2 things that you're looking for. So again, which one should you use? It's going to be up to you. You're going to have to decide that as you're doing each individual problem. You can take the equations and put them in Desmos. The problem with that is sometimes it's harder to read than it is to actually just figure it out. So again, that's going to be up to you. Plus, sometimes I'm going to ask you to do it algebraically, and you're going to have to show your work. Okay, so if you had the problem f of x is equal to 5 divided by x plus 4, and I wanted the domain of that, if I look at the graph, that graph goes left forever, goes right forever. However, this line right here in the middle, the graph never touches that there at -4. So the domain would be all real numbers except for -4. That thing is called an asymptote. That's something that we'll do in one of the later units. Algebraically, like I told you on the previous page, your denominator can't be 0. So if I hadn't given you that graph, what you could do is you would just say x plus 4 cannot equal 0 and solve it like an algebra equation. Just subtract the 4 to the other side, and you would get x cannot be -4, and that would be your domain. So it'd be all real numbers except for -4. All right, again, if I gave you the equation g of x is equal to the absolute value of x minus 3, you could take a look at it on Desmos plug it in, and you would say, all right, this graph goes to the right forever, but it never goes to the left of -3. So the domain for that would be anything greater than or equal to -3. If you're going to do it algebraically, what you're going to do with the square root problems is you're going to say what's on the inside has to be greater than or equal to, you know what, I needed this. This was supposed to be +3. The original problem was supposed to be +3. So let's make this a plus. So x plus 3 has to be greater than or equal to 0. And so x in this case would have to be greater than or equal to -3 when you subtract the negative over to the other side. Okay, sorry about that. The original problem was supposed to be plus from this graph. Okay, so that's what you would do with, if you needed to do the domain of that, you could either graph it or you can do it algebraically. I'm going to do these without ever graphing them. Okay, if you wanted to, again, you could look at the graph and see what it is. For me, I think it's just easy enough to say what's on, because it's a square root, what's inside the square root needs to be greater than or equal to 0, and solve that. So -2x, when you subtract the 6 to the other side, would be that. And then don't forget, when you divide by a negative, you have to switch the greater than or less than sign. If that's not something that you remember, then ask. So the domain for this one would be x has to be less than or equal to 3. Okay, this one we don't have a square root, so we don't have to worry about that, but we do have variables in the denominator. So x plus 2 cannot equal 0. So therefore, x cannot equal -2. So this one would be all real numbers except for -2. So see how quick that was to do. By the time you plug this into Desmos and take a look at it and try to figure it out, this was really quick to do. So again, you're going to have to weigh the pluses and minuses of doing it each way. Okay, the last one I'm going to go through is the square root of 4 divided by x minus 1. All right, we got two issues here. We've got a square root, so what comes out has to be greater than or equal to 0. And we have a denominator, and that denominator can't be 0. Okay, so normally what we would say is something along the lines of 4, that's a terrible 4. Let's try that again. 4 divided by x minus 1 would have to be greater than or equal to 0. Okay, so when you got a fraction, for stuff to be positive or stuff to be negative, there's particular rules. Well, to be positive, both the numerator and denominator either both have to be positive or both have to be negative. Well, the numerator is already positive, so that means that the denominator would also have to be positive, because if it were negative, you would end up with a negative number. So that means x plus 1 is going to have to be greater than or equal to 0. But if it's equal to 0, then I'm dividing by 0. So in this particular case, I would just do x minus 1 is greater than 0, not greater than or equal to 0. So therefore, x would have to be greater than 1. And that would be your domain. All right, let me know if you have any questions.